Okay, recording in progress. I have to assume it's taken effect. All right, everybody, welcome to the first of the intermediate data science workshops. As I mentioned, Aaron Montani is on call in an ICU tonight, so he's not able to make it. Uh, what I plan to do is to go over what was on the schedule, JASP, and also tuning several algorithms. Then I'm going to go over some what I consider is interesting aspects of large language models, particularly that I think you'll like. And then we'll probably go around and make sure everybody introduces themselves. So that being said, you might say, well, why did I bring up JASP? A couple of reasons. One is you need as many tools in your toolkit as possible. A lot of people have SPSS and they pay, to my knowledge, about $1,200 a year per head, per user for that. Well, JASP does almost as much as SPSS and would work for about 90% of the use cases you'd come up with. It again is out of the University of Amsterdam. It's used worldwide, but I think like Orange, it's used more in Europe than it is in the United States. It does have upgrades. It has a community forum. It has all the good stuff. There's a manual I gave you the link to. It is one of three that are R-based. The others are Jamovi, which is quite simple but good. And then at the other end is Blue Sky's statistics. It's complex enough that the Mayo Clinic now uses Blue Sky statistics instead of SPSS. But what I don't like about it is the graphical user interface is not at all intuitive. You have to study it for quite a while, whereas JASP is very intuitive. Multiple languages, and it again is interesting. It divides in between two schools of statistics. One is frequentist, or what we might call classic statistics, particularly with old linear algorithms like linear regression, logistic regression, and then the Bayesian school of statistics, which we use naive Bayes, but I don't think most of us actually use Bayesian statistics. The input can be a lot of things. And that's why I've used it to take from NHANES SAS transport files, which are XPT files, and convert them into CSV files. So there are, as I'll show, multiple other modules that I don't use but are interesting, such as powering a study. Again, one of the reasons I mentioned this is in the textbook, No Code Data Science, we cover a lot of aspects of JASP that complements Orange. It's also part of the open science framework if you do a research collaborative project. And we'll see here that you can save a file as a JASP file and re-upload it. You can export it as HTML or PDF, or you can export data as CSV, which is what I usually use. Now, it's not perfect. Number one, there's no module for dealing with missing data. Basically, as it starts to analyze, it just simply deletes, missing data, if you will. You can do something called Bayesian imputation, which I've never done. You can only use one algorithm at a time. As I mentioned before, one of the beauties of Orange is you can do 10 algorithms at the same time. That saves you a tremendous amount of time. Also, it does not tell you the training performance. In Orange, you can get the training performance and then turn around and do the test performance. And that's how you tell overfitting. If your test performance is way inferior to your training performance, that's overfitting. So I did list some of the other things, but I think this is just for your information of what it offers. I'm not going to go over these. I'll immediately go into JASP here. And this is, first let me go back up here. I told you already about the save. Now the open, what's kind of cool about that, it knows the recent files you've had. It also knows the organization of your computer. For instance, under the desktop and data science exercises is a folder on classification. So I have probably 30 or 40 files, CSV files for classification. It sort of knows where you are, so you don't, it makes navigation easier. Here's the link to the Open Science Foundation. You can link to a database, and also in the data library, it has a variety of data sets you can play with. You can create new data and edit data in this one. I'm going to jump immediately to descriptives and action. Yeah, let's see. Yeah, so that immediately takes the same data file we've used to teach a lot, and that's the one on predicting heart disease. As you remember, as you go over here to the right, heart disease is 1, no heart disease is 0. So when you look at this, let's look at descriptive statistics here, how easy it is. Remember that the target that you're interested in is heart disease. So you can split the data on that or not do it, but we're going to split it on those people with and without heart disease. So I just press the shift key and select those and put them over as the variables. And so it gets started. So immediately on your right, it starts to calculate. But you might say, well, what does it know to calculate? We'll keep going down and you can select. So it's going to calculate the mean. You can do this. Shapiro-Wilk is a test for normality. You can see the others here. You can do the interquartile range, minimum, maximum range. All that, as you check them, they'll show up over here on the right. For instance, confidence intervals are available. The basic plots, let's see what's checked. So you can check distribution plots, correlation plots, if you will. That's all I'll do there. Customized plots, there's a fair number of box plot. Let's do a violin. So as you do that, in scatter plot, we'll do, let's see, regression line, linear. So anyway, when you check those, now you're going to start seeing things to the right. If you want to get rid of the stuff on the left, you just hit this caret. And so now it's still thinking. It's not super fast, but you can scroll over. You can see the many things that show up here, all your descriptive statistics in the table. Now you're seeing some distribution plots. You can download those, copy it, add note, and so forth. It's high quality, by the way, because this is R programming. It uses ggplot. And so these are actually better, higher quality for a publication than anything in Orange. So just be aware that that is, these are good images. So it produces all of this. Whatever you put on the left shows up on the right. So I'll scroll down with what we have here, and you can see what it's doing. It's like an exploratory data analysis, if you will. And here is some scatter plots. There's no R value given, but you can see those, and we'll just scroll down. And it has not finished, but I just wanted to show you that's all you have to do is you click the variables or the testing and the plots that you want, and it does the rest. So that's very user-friendly. If you want more modules to explore, you hit the plus sign and you look at other things that it will do. There's a Cochrane meta-analysis. There's some stuff about learning statistics and learning Bayes if you're interested. I've checked machine learning and power only, but if you scroll through, you'll see a lot of other stuff that's there. And if you want to see R, I don't, but you can. So again, has t-test, ANOVA, mixed models, regression, and that's also where correlation is hidden, is there, by the way, if you want a correlation. Frequencies, factorial analysis, machine learning. Now let me comment about that though. So these are the regression algorithms it offers. Classification algorithms are here. This is a gradient boosting, old boosting, not XGBoost, k-nearest neighbor, a simple tree, naive Bayes, neural networks, random forest, support vector machines. These are the basic ones, frankly. but it has also unsupervised learning. So you have several choices here. I'm not going to really get into those per se, other than to say you can do that and it works fairly well. Let's, for instance, show you, let's do classification with random forest, for instance. Same thing here. The target is heart disease. Let's pull all those over. And let it do its magic. What it's going to do is divide this into train validation, which is tweaking the algorithm further to get good performance, and then it'll test on the test data. So it's split. You can order receiver operator curve. You just go down model performance. You go down feature importance. You go down and check these, and it'll do a model. But notice you'll get the results, but you won't get the training results. And that's unfortunate. I really need to complain to them and say that you really need that. And you start seeing results here. So you see accuracy is 797, and you can see all of the other ones. So this is just one more. Here's your receiver operator curve. It's one more way to do classification or regression. Do I think it's as good as Orange? No, I don't, but it does give you another source by the same token. And there's a rain cloud plot, which y'all may have not seen before, but it combines a variety of different plots. There's a distribution, so to speak. So it's several plots in one, if you will. And then the power analysis, again, I won't get into. You have to calculate it, of course, but it's just another way to do a power analysis that's fairly nice and fairly sophisticated. So again, it gives you one other tool if you need to do a t-test, let's say, to compare before and after treatment as just an example, is what it'll do for you. So that's enough said about JASP, I think. I'm going to go ahead and transition into, let me do a little bit changing here, is into tweaking algorithms. Now the tree, actually, let me go to the tree viewer. And by the way, for some of these things, and it's confusing, you need to look it up. For the tree, for instance, I need to connect it to test and score and back to the file, to the actual data. Then you can see this. And then you might say, well, how can you tweak that? The answer is you can, so it won't keep dividing forever. You can limit its depth to 4 levels or 5 levels, and then you can run the model to see if the model gets worse. It overfits because the tree keeps splitting and splitting and splitting it. It's learning signal and noise. You generally don't want it to go down too many levels, but you have control over that. Logistic regression, there's a couple of things you can do. Let me just talk about regularization, but I'm telling you, and to some degree, it's Pandora's box, because you could spend an hour explaining lasso or ridge regression or none. Basically, what regularization does is it takes the weaker variables that are poor predictors and it penalizes them. It's like benching them, making them sit on the bench because they're not performing well. And so when you use lasso, it penalizes them to about 0, whereas ridge penalizes them but not to 0. So, and if you want to vary it, now let me show you something unique, and I showed this at the last week 4, is you can actually see it in operation. Let's, wait a minute, let's look at, we're with logistic regression, and let me go back up. There we go. So let's look at the AUC as we move from lasso to ridge. Let's see, 844, 846. How about no regularization? And keep in mind, in some of these small data sets that are really overly perfect, meaning there's almost no missing data, they're linear, you've taken care of outliers, on and on and on, you're not going to see much difference in some of the algorithms, and you're not going to see much different in regularizing. But regularizing does help decrease overfitting. So your test results are going to be better most of the time if you use lasso or ridge, but not 100% of the time. But this is a penalty for weak variables, weak predictors. That's what it does. It applies a penalty, and you test that by looking at the test data. And let me be sure, we're on test here. Remember, when you use this, you're looking at training data results. This one, you're looking at test results. So let's look at a couple others. Random forest, the main thing here is you can change the number of trees. An average number of trees is 100, but it could be 200, 300. You also can limit the depth of trees and experiment. One of the things I can't emphasize enough is experimentation. In other words, you could look at the results just like I showed you. You could go from 200 to 400 trees and see if it really made a difference. Now, one of the things we're going to look at when we talk about imbalanced data where you have too much of one class, not enough of the other, is clicking this balanced class distribution. That's one of the most legitimate things you can do. And notice in logistic regression, you also have it. So those are the two algorithms that and we'll talk about that when we go over class and balance. That's very useful. That's not controversial. Now, gradient boosting, in this case, XGBoost, remember you have a drop down. There's several boosting algorithms. You have a couple of things. Once again, the number of trees. Learning rate is called eta. Here, if you make the learning rate slower, it takes its time, it's more accurate, but you may need more trees as a result. Again, not particularly intuitive, but once again, experimentation. Notice the depth of trees again. So these are all, and once again, look at regularization. Let's just for the fun of it, look to see. So that is part of it. And what's nice about this is if you were writing Python, you would have to remember all of this. This is already set with a default, which really makes it nice. Now, I'm going to suspect that regularization is not going to help much. Let's just see, because I think this data is pretty clean, maybe, unrealistically clean. So let's look at mainly the AUC. This was a low level of regularization. Let's make it even lower. So we're starting at 827. Let's go up 836. It did get better. 840, it's making a liar out of me. Now we're back down to 829. But see, you can tweak it to get the best possible AUC, 844. And so we did accomplish something by doing that. Now, whether the other ones, like say, let's look at the F1 score, did that change at all? So it's at 742. Let's go down 721. So sometimes you can't have your cake and eat it. Your AUC may be better, but your recall or whatever may be worse. But I hope you by now understand the importance of experimentation. The person who co-wrote the textbook that I had, the No-Code Data Science, went over everything that Orange had and tweaked it every possible way, and he came up with 1,200 possible nuances, options of how you can tweak it, which was pretty impressive. Let's see, I'm just looking at the chat here. Okay. So in any case, let's look at a couple of more here. K nearest neighbor, again, is very rarely used by itself. You can adjust the number of neighbors. the distance is Euclidean, but it can be Manhattan. You can change it and see, but I don't know if anybody that uses K nearest neighbor. It's used for other things, but not as a primary algorithm. Now let's get something really interesting, neural networks. This is the number of neurons in a hidden layer. First of all, you see the comma? What this means is there's one hidden layer, one only, but there's 100 neurons in it. And you might say, well, what the heck? What's the rule of thumb? Usually you start with 2 or 3 hidden layers. This is one. This is the default to my knowledge. So you could add more hidden layers if you want to. And then the number of neurons in a hidden layer is usually somewhere between the number of variables in your input and your output. That's a little bit confusing. So 100 actually gives us pretty darn good results, I might add. Let's get down to neural network. So here's an example which is surprising. I've played with this a little bit and notice the AUC for neural networks pretty darn good. Recall 735, which is sensitivity. Let's see how that compares with logistic regression. Actually, that means it's the best. We may want to leave it at that, but let's go and tweak it and see what happened. Let's give it a second layer of 100 neurons. So it's got 2 hidden layers. Let's see what happened. So let's see now. What was recall before? That's still the best. I don't know. Does anybody remember what the AUC was before? We can go back and tweak it again. But the point is you can change this. And that's trial and error. That, you know, there are rules of thumb, but not very good ones. So this tells you there's 2 layers, one here, hidden layers, one here, and there's 100 neurons each. Now, what is activation? That's another confusing term. You know, a neural network is a lot like linear regression, except it can handle nonlinear functions, including images. The only way that can occur is have an activation step to it. And what that does is it really decides, it's like a threshold or gateway. And what ReLU does is if your number is positive, let's say you've added up all your weights and that number is 100, it passes 100. If it's less than 100, it does not pass it. You know, so if it's -2, that gets passed as nothing. So this activation level is really important. The other thing that's important is something called a solver. That's an algorithm to minimize loss, to make it as efficient as possible, if you will. You can set once the number of iterations that it works, you can set that and experiment. And lastly, I've already explained regularization, which helps overfitting. You can set that. So I think you can see why I'm saying there's all these options. And that's what we'll see when we look at regression, that I basically, remember, you can right-click these and rename them. So you can rename this neural network 100, then do another one, neural network 100, 100, and keep track of all of it and save it to remember what worked the best. But again, look at the number of parameters or possibilities here. They're quite a bit. And so to really maximize an algorithm, you would tweak all of these. Sounds painful, right? But at least in Orange, it's not as painful. When you can do this and see what's going on with the algorithm and watch it changing, and like with regularization, let's look at the AUC again, 857. Whoops, it's still thinking, that's why it's doing that. Hadn't changed there. Let's do it again. So it decreased. So it was too much regularization. But the point is, this is fantastic that you can tweak the algorithm and look at the results. That saves you an incredible amount of time. Can you imagine writing code every time you did that? That's what you would do. All right, one last thing on the classification scheme here. I mentioned last time that if you like the model, for instance, I think we found that logistic regression seemed to be the best, although today it looks like neural network is. The point is you could save whatever that model is here as a pickle file, PIKL file, then you can load it. You save it, you remember where you saved it, and then here you open it up, you go find it as the save pickle file, and then you can make a prediction. In other words, you see how well it does by opening it up. But the point is, this is so you have a save model and load model. So that's available in orange. Let's go to regression and talk a little bit about that. It's not going to be any difference. Tweaking, again, we talked about the tree, we talked about tweaking random forest, gradient boosting, we talked about. So all these things have some regularization. Remember, the chief goal of that is to decrease overfitting. So the testing data is better. Otherwise, it's going to be much worse than the training data. Another thing that you can do, by the way, is you notice here, linear regression, no regularization, linear regression, ridge, lasso, elastic net. Now, what is elastic net? Let's open this up. Elastic net is really like a combo between ridge and lasso. And you can adjust how much. So lasso is L1 regularization, ridge is L2. This is just a balance. If you want mainly ridge, you shift it over to the right and so forth. It just gives you one more option. So you've got those four options. And that's what I'm showing here. So up here, this is another way you could do it if you had regression. You could look at this, and this is on the test data. And remember, you want the highest R squared, which in this case is for no regularization, and the lowest either mean square error, pardon me, and the lowest root mean square error. Because again, you want that line, that regression line, to fit as many data points as possible. So the error between a data point and the regression line is as small as possible. So the best results are the smallest results, with the exception of R squared. This is, by the way, not a very good model. R squared should be more like 0.8 and something like that. So it's not a very good model. But this shows you how easy it is. And if you say, well, I want to see regression, or excuse me, the coefficients, you can do that. You can open this up, and this tells you, this data set, by the way, is choosing wine quality, and I don't remember if it's red or white. But so it shows you, the reason I put this select column is so you can see what the variables are, but you can adjust it and watch the coefficients change. And this is, remember, it does, so that's the lowest to the highest, if you will. So sulfates seems to be the highest coefficient next by pH, and then alcohol. But for each one of those, if you wanted to see the coefficients or you wanted to watch them change, you connect the linear regression to the data sampler and then connect it to a data table. Let me see if there's anything else that I overlooked. I didn't want to get into more detail than that. I'll remind you that if you're interested in what is going on, that the feature importance widget is very valuable. So here's R squared, which I mentioned is really important. This is for a different data set, not wine, that gender was most important. So as you go down here, you can see that. But the nice thing is you can adjust it. If you want to say root mean square error is the most important thing, it will calculate, and again, once again, gender. So this was a data set to I changed it. It's not life expectancy. This was a data set to predict grip strength, as I recall. Yeah, to predict grip strength. So those are the tweaking. I don't think it deserves more detail than that, to be honest. What I want to do, unless you've got questions, let me just look at the chat. I want to shift to the presentation that I gave at lunch today for the board review course. First of all, let me ask you, do all of you use open evidence? Feel free to unmute or chat or whatever. I'd be curious.
Hey, sir, this is Jason Lanning. I do use it a little bit in my practice.
Okay, good. Well, I'm going to go ahead and quickly go over it because I think this is one of the win-win. Certainly not everything in AI is a win-win. So I'm going to present two aspects of it. Let's start with an important one. For instance, there are tons of GLP-1 agonists out there, Ozempic being one of the leading ones. And I would have to ask myself, well, but what are the contraindications? I just gave it to 5 patients, uh, one of whom didn't have type 2 diabetes, let's say. Uh, and what do I need to know about that? It's a very quick, wonderful way to get to it with references and the ability to quiz it. So you can sit there and ask it other questions, common side effects, and so forth. I've not found it to hallucinate. It will take you, again, hyperlink to the actual reference. It's available for the iPhone. You get a weekly newsletter. Uh, this was created about 6 months ago by MIT and Harvard. Keep in mind that UpToDate is madly trying to come up with a large language model embedded in UpToDate. So you can query it. Let's say you had a question about lupus. You might have to look at the chapter in connective tissue disorders, nephrology, dermatology, cardiology to get the answer because lupus affects multiple systems. Whereas if you had a search engine, you might ask a very pointed question, like what's the overlap between, say, lupus and scleroderma? You can be very pointed. You wouldn't have to go look at the index or table of contents. So that's coming your way. It's just a matter of time. The other thing I want to make sure you're aware of that this was called Open Evidence Part 2. When you hit that, suddenly you realize it will do construct a workup for you, talk about guidelines that are out there, compute formulas, treatment alternatives, calculate a risk score. I don't know what a tough question is, by the way. I haven't looked at it. Uh, Ask in a language other than English, quick fact, drug side effects, labs. It will create a table for you, ask about drug dosing, on and on. I think one of the good things, though, is it'll do board reviews for you. But here's write a prior authorization letter, write a patient handout. All those are pretty good things that a busy clinician could take advantage of. So that's the reason I'm mentioning that. So number two, let me get my list to make sure I'm in order here. You might say, well, why am I demonstrating perplexity? Well, all these things continue to change, if you will. Uh, Let me go to this one. We all know Perplexity does a good job as a search engine for academic and non-academic things. But within the last week, they added DeepSeek R1, which is a reasoning large language model, and O3 Mini, a second reasoning model. And I'm going to introduce a third that came out yesterday, Gemini Experimental. So you now have reasoning ones. So first of all, what I did is I cut and paste a MedQA, same thing as USMLE question, a lady with an obvious myositis and muscle weakness, and it got it right. The answer was she needed a muscle biopsy. That was correct. But what I was more interested in is how did it think about this? Well, first of all, it gave 40 resources. The average, if this was in GPT 4.0, it wouldn't give 40 resources. But what caught my attention is its thought process. And you can drill down this further. Okay, let me try to figure this one out. Gives you the introduction, ductory thinking, and it just keeps going. All these different steps, tells you what it's thinking. It goes back sometimes and say, well, wait a minute, I need to think about this further. So I think this is really fascinating that it'll do that. And you can save it. You can, over on the right, search images, search videos, generate images. It can do all that, but there's 1,000 ways to do that today. It does another thing, is you can create, see if I can find it here, convert to a page. What is a page? A page is really kind of and let me get one here. I asked it to create a blurb on AI and biomedical manuscript review because it's a subject I'm researching. In other words, should we use A to help with authors or peer reviewers? And I wanted to see what it came up with. But it gives you the start where you can go in and edit and add and so forth. But so this is just one more source of information written like an essay. There's several others. We're going to go into Google Deep Research in just a minute. Let me look at the chat for a second. Okay. And what I'm going to show you is this next thing I did is I downloaded DeepSeek for my computer locally. This is not the full however many billion parameters. This is 14 billion parameters, but this is on my computer locally, not on the internet. Okay. You use two programs. You download a llama first, and then you download anything, and that's in the upper left, anything LLM, and the rest is pretty intuitive. But what is kind of interesting about it is, once again, the thought process. So here's a data set on breast cancer. Perform exploratory data analysis on this data set. All right. So I'm trying to, I think it's funny that it said all right. But first and then next, checking for missing data. I didn't tell it to do that. Then I should look at variable distributions. Again, didn't tell it that, for categorical available by bar charts, pie charts, blah, blah, blah. Subgroup analysis. So it went through a nice thinking episode. Interesting enough, I think this is reasoning. Anthony Chang thinks it's just parroting. So it's an ongoing debate. You have to make up your own mind what you think it's doing, okay? Whether it's really thinking and reasoning or not. So anyway, it did that. And then I had it basically report this, but it didn't publish the findings like some of the other programs that I use. But I didn't tell it to use Python. In other words, it doesn't know that I want the actual results necessarily, which is sort of interesting. So I'm going to have to treat this different with a different prompt. But so the point is, A, you were able to see it think again, and B, you can have this on your computer if for some reason you want to have a large language model that you're using yourself. This is another way to do it. So I'll mention that. All right, next, Gemini. What I wanted to show you about that is, and this is brand new, hot off the press, is Gemini was, up until a day or so ago, just 1.5 Pro, even though with Google Notebook LM, it's 2.0. But so this is what we're going to demonstrate. But lo and behold, look up here, 2.0 Flash Thinking Experimental. So this is another one where if you give it a medical scenario, it'll tell you what it's thinking. And let me just see, I think if I can get the library here. Yeah, I'll show you that. Here we go again, 48-year-old lady with muscle weakness and whatnot. It goes through the same sort of thing. tells you none of the above. This is less likely. And by the way, the older large language models don't do very well with none of the above or fictitious data or modified data. It does better with if there's a known answer. But my testing so far, and I really like to do this in detail now that I have two, I really have three thinking models. I want to see if it handles the unknown better and doesn't hallucinate. So again, once again, it comes down to the bottom line, and you can see how much text it generates. Muscle biopsy is the most direct and confirmatory test, okay? So let me go back here and show you. So what is deep research? And now I've checked 1.5 Pro with deep research. Basically, again, it gives you a much longer, comprehensive analysis, if you will, although you saw that Perplexity AI is nothing too shabby using, deep Seek or O3 Mini gives you a fairly extensive write-up on a subject. So this was basically, I asked it how AI could be used for improving telemedicine. So it gave you the current state limitations. And this was nice. It created a table. I didn't ask it to. And you can export that to Google Sheets, which is, I think, convenient as well. So here are some of the things that it gives you. It gives you the references. I'm not going over this in tremendous detail. It's also a subject I don't know a whole lot about, but I think this is another resource if you needed to do a write-up and you wanted to get a head start. Again, this does not replace a human. I want to make that point loud and clear. But if it jumpstarts a workup you need to do, it saves you time. I don't see what's wrong with that. But the onus is on you to confirm the references, do your own research. So it researched 36 websites. You can go or each one of those. My experience, it researches roughly 35 to 50 on average. But also you can open it up in Google Docs, which then makes it something you can export and do other things with, if you will. But what it does, and I didn't really start that, is it gives you a plan of what it wants to do. You can modify your plan, by the way, but once you think the plan is good, you click Start Research, and then it spits it out, okay? So it does give the option to look at that with, your critique, if you will. All right, let's see, I think that's all I was going to present. We're going to present the week we're going to talk about Google Colab. I'll give you two examples of AI data analytics. I won't do that today. I'll save that. But what I was saying before some of you logged on was that I would like to have an AI sharing period. For instance, I want to demonstrate Napkin AI, if you've never seen it, a couple of other things that are very useful. Please let me know if you have one that you think is really hot that you can present or you want me to present, because nobody can keep up with all of this. This is a full-time job. I mean, believe me, I spend most of my day looking at new articles and new innovations in this area. So feel free to email me with something and we can share it or however you want to do it. Does that make sense? Please feel free to unmute and so we can discuss that. Because we're at the end here. I wanted to have people go back and introduce themselves so everybody knows everybody else, but also an opportunity to just say what else you'd like to discuss, and do you think the AI tools is a worthy section each week? So let me let's pull up the list. Steve K., you want to go first?
Uh, yeah, hello, I'm Steve Klankowitz. I work for Precision Bio, which is a pharmaceutical company which is heavily focused on AI. Physician by training, been in the pharmaceutical industry for about 25 years. Before that, about 10 years clinical practice, Air Force and flight surgeon. And this is extremely helpful because I focus on kind of drug safety and looking for new ways to do clinical safety monitoring in the AI space.
Okay, great. And actually, the way you put your last name threw me for a curve. So, but anyway, one thing to comment on is the last chapter in the book, No Code Data Science, was written with all the process improvement bells and whistles in mind, meaning Dave Patrishkoff was able to see where AI could really help safety and analyzing different processes. He could save, I mean, he did an analysis of a practice looking for different kinds of improvement. And within a short amount of time, he had a 30-page document going through all kinds of analysis of different kinds. And so I would hope that you would employ AI or figure out a way to make it expedite any kind of safety or quality improvement or whatever, because it can go through things like SWOT analyses and 1,000 other things. I'd be happy to send you that chapter if you like, but it's just it's really a bright area, and it's where AI is least controversial, I think. Um, so thanks for joining. So Carice, you're next.
Sorry, hello?
Carice, okay, yeah, we can hear you now.
Yeah, I'm Carice. I'm in public health and medical education.
Okay, so how is, I presented a few things that are relevant to medical education. Where do
Mhm.
you see AI helping you?
Well, so you were mentioning, well, I work with primarily with medical students. So I think, mm, well, as an educator, probably it's helping to develop certain scenarios to help my students learn.
Okay.
Um,
There's one thing that is of interest to me. Have you looked at the Khan Academy's large language model known as Khan-Migo by any chance?
nope, I had no idea about it.
Okay, well, let me explain what it is, why it's interesting, because I really worry a little bit about AI and medical students because we have to teach so much to them, plus critical thinking. What I don't want to see is AI overcome critical thinking. There's good evidence, by the way, I can send you a study that suggests that AI does just that. But so what Conmigo does is it tailors it, the education, because so much education is aimed at the middle, meaning you're not doing much for that super bright student and you're not doing much for that student who's struggling. Well, Conmigo, immediately as you start talking to Conmigo, it recognizes, it quizzes you, and if you miss it, it goes back and say, well, let's go over that again. And it slows down or speeds up accordingly based on how much the students know. So my feeling is, I think that would be a winner if it just served to be a tutor.
Yeah, a
In
lot of
other
my
words,
students are using it for like, learning, like as their tutor for step one and things like that. I want to use it more to integrate it into case analysis, but I also don't want it to take away their creativity or their thought process. So it's a struggle to figure out where the balance is.
yeah, I am completely in agree, and I don't think I have the answer, but I don't think an extreme view is the right view, meaning no AI at all, or have AI totally embedded in their education with little else. I think that would be a huge mistake. That's like not ever commenting on soft skills like bedside manner. That would be, really regrettable. So no, please stay in touch about that, because
I mean, I
uh,
can see like on the instructional side, I see the total advantages because it makes it so much easier for us to think about elements of a case we'd like to add, and so on. But on the student side, to help them learn, I'm really conflicted.
yeah, well, those are all legitimate concerns, extremely legitimate concerns. So, keep us posted because there's really no immediate quick answer. Fazal? Fasal?
Hi, Bob. I'm Faisal Syed. I'm a cardiac electrophysiologist at UNC, and I'm interested in AI, and I've been using AI for some of my research, and also on a day-to-day basis with um, so many practical aspects now. So I really valued these sessions that you had over the last 4 weeks. I've tried to join whenever I can. It's always at the end of my lab day, um, but really fantastic. And the reason why I joined was because I wanted to learn or get an insight into Orange, which I don't know how to program, but I understand AI. I've actually attended the ABAIM's courses, and I've been invested in educating myself in AI for the last couple of years. So I just wanted to see what the capabilities of this software were and how I might be able to use it for my own research. And I learned a lot. It was really well done. And thank you so much for getting this together.
Well, it's great. And I would hope that AI would be helpful in the EP world. I mean, in other words, it's so helpful to see things that, uh, the human eye can't see necessarily, and to aggregate data from multiple different areas, genomic data, phenotypical data, you name it. It's about the only way we can ever practice precision medicine, is by having all that information aggregated. But if I see an interesting article with AI and electrophysiology, I'll let you know.
Yeah, that'll be great. Thank you.
Well, thanks for joining.
Sure thing.
Okay, Jason?
Hello, sir, and everybody out there. I'm Jason Lanning. I'm a internist and a brigade surgeon in the U.S. Army, getting ready to transition out. My interest in AI goes back to when I did the beginner's course back at the end of last year, and learning more about data analysis as well. Looking into the civilian side of things, looking into some of the positions for medical director jobs with some of these insurance companies. It seems like they are really trying to integrate AI into some of their processes, as well as some of the data sciences, and looking for more of the requirements when people are applying. So that's what really has driven my interest. And I've appreciated the courses over the past several weeks, and looking forward to these next few weeks.
Great. Well, I think there's no question that if you're looking for a job, having some knowledge of AI is a plus. It's like being bilingual, if you will. So it's to your credit, and I think that you could be a leader in many areas, be it, if you opt to go to industry, let's say, instead of clinical medicine, it's still valuable because AI is not going away. It's only going to get better, which in a way is scarier because if it gets better, it's going to replace more jobs, I'm afraid. So we have to be a little bit careful what we ask for, but still, I think if you can interpret it, you can translate it for people, that's valuable. If you're somebody that says, well, uh, this is what we know today, that's really very valuable because a lot of places are still in the dark. There are not many Stanfords out there. I mean, Stanford is hot and cold running AI, without a doubt, but a lot of places just are so far behind compared to them. So, yeah, it's funny. Sorry, I didn't attach your last name to the Army. I remember you were getting out. And certainly I had 3 years of Army and 17 of Navy. So uh, trust me, I understand the military experience, but you're never too old to change professions or learn new tricks. So hang in there. Okay, Samudani?
Hello, can you hear me?
Yes.
So I'm Samudani. I've been in a member of this ABAM course, and I participated in the previous course, the previous 4 days also. I'm a researcher, and I'm really interested in AI because I like to call myself as an early adapter. I try to use AI to make my life easy in terms of doing work effectively and find solutions, and also do productive research.
That's great. And I do think AI will help research quite a bit. I think there's this unfortunate problem with plagiarism and
Yeah,
what,
that is
yeah,
there.
I think though, I mean, I had a thought the other day that I thought that the publisher should use AI and announce it to the author. You've submitted this article. I've found the following 5 deficiencies. You didn't mention sample size, you didn't do whatever. Send it back. It comes back, then it goes to the human reviewer. But I mean, I think some AI somewhere in the middle is warranted, particularly in data science and AI, where sometimes the writing isn't that good. People leave out stuff. English may be a second language. There's just certain obstacles, but I think AI could help that, but it has to be 100% transparent.
Yes, that's the thing. Like, I think we have to learn how to use it ethically rather than like attacking that it's not good. Like, we shouldn't use AI or anything. Like,
Yeah,
we have
well,
to
I
be
think,
transparent because otherwise people will use it secretly because
yeah,
of the.
yeah, unfortunately, it's like they tried to have prohibition back in, I think it was the 1930s, and nobody could have any alcohol. That proved to be a joke. So telling people, medical students, to never use ChatGPT to look up the differential diagnosis, that's going to be that's a failure from the start. So I think, just like you said, it's all about intelligent use, not abuse, but use
Yes.
of this tool, because it is a tool. So, no, I'm glad. It's nice to have somebody in research. Okay, Mark Polar.
Hello, I'm uh and what my camera is blurry there. Uh, I'm an anesthesiologist at the Geisinger Health System in Pennsylvania. I'm a chief of service, so I'm trying to figure out how to use this to run the service. But I also have research in genomics and personalized medicine interest. So I'm trying to figure out how to use it as a tool with frequently limited data sets, but even more so, I think, for using it as a tool for sifting through the massive amount of data to find the pearls. I
Well, that's
don't,
great. So, do you think that Geisinger is receptive to AI as a general concept?
oh, very much so. We actually employ a number of data scientists and actually have um, a, a chief data officer and a chief AI officer and a medical director of AI. So we have a lot of that integration already in the system. But it's mainly being applied to things where uh, leadership has decided to apply it. In the population health side of things and primary care, and anesthesiology is kind of a invisible service to most of the system. They expect us just to make things work, but when it comes to asking for their help to actually do something or, for instance, an internist might have an hour to see a patient and to sift through the record. I have 10 minutes to see a patient to figure out what's going on with him and then to take his life into my hands while they have surgery. And, to have AI tools that could comb through a patient's entire record and find the important pieces and put them together as a meaningful digest in a few minutes as a tool to help me would be vastly helpful. But the system isn't interested in helping me with that. Just go do the cases. So
Yeah, they're only interested in throughput, and unfortunately, how many cases per day. But it's funny, maybe 4 or 5 years ago, I said the whole solution is just integrate AI with electronic health record. But then somebody smarter than me said, the electronic health record is full of errors. It's like 30% incorrect or missing.
or
And
more.
so that's going to be a real dilemma because we all want what you're talking about. We want a longitudinal summary of the patient with even some forward thinking based on knowing their past. Here's what you should think about. And then if it knows the genomics and family history, maybe some honest to God projection of saying this patient needs this genomic test or whatever, their risk of, whatever, GYN cancer is particularly high. I don't know. I don't know in my lifetime we'll see that. There's no question we all want that.
Well,
But
we're
there's
actually doing that. Well, I don't know if you've heard of my code, but at this point, Geisinger has the largest genomic database in the country, not quite the world. Iceland has a little bit larger, but we have 350,000 of our patients who have signed up to have their entire exome sequenced, and over 250,000 are already done. Out of those, about 2% are found to have actionable genetic results from the American College of Medical Genetics, which range from arrhythmias and hyperlipidemia, Lynch syndrome for cancers, breast cancer, many other things. And those patients who actually have actionable results receive genetic counseling and oftentimes actionable surgery or other events, or simply put on more careful surveillance in order to detect the things that they, like the multiple endocrine syndromes that they might be susceptible to. So we're actually practicing genomic medicine. In my case, in anesthesia, we've actually published this. We detect the RYR1 gene for malignant hyperthermia, which it turns out only about 1 to 2% of the people who have the gene actually express it. We were very surprised to discover that 1 in 600 of our patients actually carried that susceptibility, even though only 1 in 10,000 or 20,000 actually has an event that's life-threatening. But now we have every single chart that's known to be RYR1 positive flagged, so that in 3 years, I don't think that we've given a single we've given one triggering anesthetic to a patient who shouldn't have had it.
No, that's great. And I know that, All of Us, there are many other programs out there collecting genomic data, but how many have actionalized it like you all, I have no idea. So that's great. And again, hopefully AI will help aggregate the data together and make something that's really meaningful. Okay, Sean, you're last but not least. Are you still there, Sean?
I think your lips are moving, but we're not hearing anything.
Okay, let's see. He is muted. Let's see if I can unmute him.
I'm so sorry. Yeah, thank you.
Okay.
Yeah. So yeah, hi, I'm Sean. I'm a medical student from India, and I'm very happy to be a part of this journey and this group. I joined this because of ABAIM, and yeah, like Samadani said, like I just want to be an early adapter, and and see how data science and AI takes me ahead, not only in just how I study medicine and all the things that you were talking about, Khan, Migo, and different AI tools. And these all are truly important for me. I mean, even for my STEP exams, when I'm preparing, I was using ChatGPT a lot so as to reason through many of the topics. And it's quite futile to stop us medical students from using ChatGPT, I must say. But yeah, so I feel there's a lot going to change ahead, and it's better to be on the accelerator, just seeing what is going to happen and not miss out on anything.
Okay, well, it's nice to have you. And, again, the earlier you learn, the better. And obviously, India is very involved with this. And I'll be happy to send you a link to a Dr. Day, D-E-Y, who holds, I don't know if you know him, Amit Day, who does international seminars in AI and whatnot between India and the United States. So there's a very big audience, needless to say. Okay, so I think that wraps up week 1 of the intermediate course. We're going to reconvene in 2 weeks. A week from now is I started to say Halloween. No, Valentine's Day. Quite a bit of difference. So I didn't want to occupy your time when you're supposed to be taking out your better half to dinner. So we'll reconvene in 2 weeks. I'll send out other emails, maybe with some handouts. We'll see. But do let me know if you have any topics that you think are AI tools worth mentioning. I'm perfectly happy to do that. So otherwise, have a good Super Bowl weekend, and we'll see you then in 2 weeks. Goodbye, everybody. And this is recorded. Hopefully, I'll send out the recording to everybody else.
Thank you. Bye.
Take
Thank you.
care.
Thank you.